going to tell you that. I was fast at this. Now I'm going slow today. But when I was on line mechanic, I didn't let things slow me down because I memorized stuff like this. My memory works that way. You probably gathered already. I'm one of these guys that I remember little details. And I found out as a mechanic it helped me to know what things inch and equivalent, metric equivalents were. If I couldn't find that inch socket or that metric socket, I know it's costing me money. I roll with it. I go with the opposite. I'll use the inch one instead of where I was missing a metric and vice versa. And it actually helps you. These are some of the things I'm talking about. Now, I got this assembly off. I'm keeping the screws for that together. I'm going to put this assembly together to when I put it back together, those components will be there where I know where they are. Now, this is not my first rodeo, and I know that if I want to take the carburetor off of Briggs & Stratton, because I'm going to tear the whole engine down, to take this engine apart quickly and get the carburetor off quickly, it works better to get the muffler and the blower housing off. Now, do we actually come up with an inch set yet? All right, I can go over to my box at this point. I'm going to run out of equivalents here in a minute.
Is it not in this one?
No, it's not metric. This is inch. Oh, you got a metric. Again, as I do this, I want you to notice I use extensions quite often. Once I use the extension or deep well, it lets me work on this and get down in places so I reduce the risk of scraping my knuckles. And even though I didn't need an extension for up here, I knew I was down here, so I put it on already. Again, it's a thing about saving time, okay? And this is a pre-thought thing. Somebody said, well, why are you using an extension up there? Wouldn't that be better just put this on there? Well, I run the risk of scraping my knuckles on the engine, but later on, am I going to stop to go look for the extension? No, I've thought ahead of time and say, I know I need an extension for this around the bend. So I'm going to have the extension on it already. I don't want to have to go look for it. All right, now my logic here was, it's easier to get to this bolt on the carburetor with this blower housing missing. Easier to get to the bolt over here with the muffler missing. So I'll remove it. This is going to be torn down. Now, this heat shield right here gets left off quite often. I want it taken off just for you to look at everything. But make sure you don't misplace this. We got a couple of them missing already. I don't know what people do with them. They take them off and then they disappear. Are you kidding me? But again, I want you to see how the cooling fins are arranged and stuff. In this case, I put the bolt back in so it doesn't get lost. A bolt that size is easy to roll off your bench and lose. So I'm going to bolt it back in place. Oh, that's good. I like that. Now, we are not overhauling carburetors. that's a completely different section. I just want you to get the carburetor off because this assignment here is focused on you learning how an engine is built, how to measure the engine, how to set camshaft timing, how to reassemble an engine. This is not a carburetor lesson. So I want you to take off the carburetor as a complete assembly. Don't tear it down. That's not what this exercise is about. There'll be times later where you're going to take a carburetor completely down. This is not that time. So while this goes down, again, muffler's off now. I'm going to leave the bolts in the muffler right there ready to go. Say, for example, you were tearing this engine down because maybe it had a rod knock. Well, that rod knock doesn't usually impact the muffler, the recoil starter, the carburetor, and all this. You just need to get this stuff off and out of the way so you can get to the work you need to do. So that's why you want to keep it together and organized. Now, the way this, for your benefit, this was yours, right? I haven't used it. Where's your 10?
It's on the extension.
Oh, that's right. Yeah, I want to put it back because you didn't need that one right now. All right. So anyway, now you got 2 bolts up here, and you got one down here. That this carburetor is on a bracket, so that this whole assembly can come off. We need a 3/8 wrench combination. And they've done this funny. They've actually, because of the type of tool you have, not all tools fit in here very well. You can use an open end if it's not over tight. You have the option of using a Torx. So what I do on this, I'm thinking again ahead of time. I'm going to leave that top bolt there. I'm going to loosen it, but I'm going to let it hold the carburetor in place while I take out the other bolts. Now here's the thing with this. If you take some of the bolts all the way out, then you got to deal with holding it in place. You're going to find out certain bolts work really well. Loosen them, let it hold the components in place for you while you're loosening up everything else. All right, on this engine here, I'm going to take the carburetor assembly off, but at the same time, this has the engine controller, the throttle, and the kill switch on it. Now the kill switch actually has a kill wire going to the magneto. So I'm going to disconnect that and just drape it up here, because I'm going to take this assembly down, leaving the kill wire on it and so forth. And as you're working, please feel free to move around so you get a good view, and then maybe get back out of the way and let other people see too. This will eventually loosen up enough where you can actually take this bolt out with your fingers. So right off the bat, you can mark your muffin tray or whatever and decide, okay, everything with the carburetor I'm going to put down in this one corner. And you can take a permanent marker and mark as to what bolts went in there. once you get it off, there's a vent tube that comes loose. And on this engine here on the Briggs, you find out a little trick. You take it to the corner of the table, and I can pull the governor linkage off by holding it, removing the spring. Again, take your time and watch what you're doing. See the relationship, how the governor hooks up to this. Leave all this together. The linkage, don't damage it. Don't force it off, but right here I tilt it out, I can disconnect it when I go back. I can hook the spring back up, hook this back into the hole, like so, and put it back on. So this, I don't want to damage anything, and I don't want to change the base adjustments. I'm going to set this over to the side. That last bolt, carburetors. Now, one of the things I do to remind myself here, I can mark it. Carburetor gasket. That is obvious, a carburetor gasket. I'll put it with the bolts. So that then again makes it obvious those are carburetor bolts. I put associated related parts with it. At this point here, there's a couple things I can do. I can take the valve cover off, take the flywheel off, take the magneto off. Magnetos are kind of fragile, so what I want to do, I want to get the magneto out of the way and then do the valve cover and then get the flywheel gone. Now, being that I know that there's a magnet in here, I can actually use this as a holding tool when I take this off. This is where you do the air gap, by the way. As I loosen this, you'll find out that that assembly, did you hear it click? It gets sucked down onto the magnet. Once it'll keep it there. And once I get the bolts out, and this is just one of those little tricks. It goes a little faster if you have a nut driver, because ratchets are a little slow once you've broken loose. I'll take the screws out, and then I can take this off. Just fold it away. The magnet held it in place. All right, with that, I'm going to put the screws to that there and stick that in my organizational tray. This is now look at this little trick here. I like this feature in some of my nut drivers. Like, I know I want to use predominantly the nut driver as a thing of speed too, but sometimes it's too tight to use, so break it loose and I've already got it set up to use the screwdriver. See what a neat feature that is? I love getting a nut driver with a ratchet drive in it.
What kind of nut driver is that?
There's several brands that do it.
Oh, really?
This is a pro. This is a proto.
That's the
What's that?
Silver Eagle set has it.
Oh,
Yeah.
really?
Several of them do. I always look for it.
Cool.
And I made a point to put one out without it. This is a Craftsman. Not as convenient.
Sweet.
But again, this is some of the stuff that I pull out certain things to show you some advantages to it. This is the crankcase breather, and it has a little damper in it that as the positive pressure changes in the crankcase, it controls the air output and also the vacuum to recycle crankcase gases for lower emissions. And again, the screws go together for that. Those parts are put together. That way, if the bench gets bumped and stuff like that, it's not going to go flying. All right, now I can show you something here. I can do it the other way, but I'm going to show you this. This is the flywheel, the strap for holding a flywheel. And how this works is you put it around the flywheel and you tighten it. That's you tighten it up in here, and what this does, it pinches it. You take the extra cord and you wrap it around the handle like so. Then as you rotate the flywheel down, it wedges it, and you can hold it while you take this off. I need a 15/16 half-inch drive, an impact if you got it. Do you have an impact 15/16? You do? You want to grab it? All right, now what I'm gonna do here, if you go by the book, it will use a breaker bar, use this strap. I look at this, look, this is like watching a monkey trying to perform some operation with a football. Not gonna go there, you can figure that out. But anyway, the point is, the way this thing works, it pinches the strap into it. No, and by the way, I don't like putting it right there by the aluminum. I like it on the hard part. As this folds over, it clamps it. And then you can use a breaker bar. But here's the thing. The torque on these flywheels run anywhere from 50 to 70 foot-pounds. Then when you break it loose, which means you're gonna be having to apply a pressure of probably 100 or so.
Do you want the impact camber or just want to have ratchet?
I got an impact. I don't see the 15/16s.
No standards? No. Just grab this.
Anybody else got a 15/16?
I have a socket, but not an impact.
Or a 24 millimeter, same thing.
Not as an impact.
It's not that tight, I can do it without one, I'd rather not. So I'm getting you guys involved. Then getting set up for the next thing. On your 3/8 set, I need a 1/2 inch on your ratchet, snap-on ratchet. 1/2 inch with the breaker bar. And then a 1/2 inch with ratchet also. All right, while we're waiting for that, now look, when you're doing head bolts, you can use the ratchet, but it actually puts undue stress on it. It's best when you're taking something like a head bolt, and remember the thing, you can say, oh, you use an impact, but then again, anytime I'm dealing with head bolts, I like to use breaker bars for the story I told you about Jeremy, right? You got one? What's that? 24? I hate to, now look, we didn't have a 15/16. Again, I know a 24 is an equivalent 15/16. Again, do you see how that's saved? We could spend, how much time do we save looking, I already spent looking for a 15/16?
Too much.
Yeah, we've already spent several minutes. Again, this is part of the demonstration, say this is what you don't want to happen. But at the same time, I said, okay, you got 24? Now I can get back to work. I've already wasted enough time. So, now with this on the top, I can actually go ahead and you're going to, now this again, so let me have a deep well in this. I tell you, I'm a big fan of using deep wells. You save time. Again, this is from experience. If you're using deep wells, you're going to find out you'll save yourself some time because stuff like this will happen. 1/2 inch shallow works for that, but what am I going to use for this? You know what I mean? So, now these usually goes at an angle Now, I gotta tell you, when I'm sitting around, I don't have mine handy. I have a piece of pipe that I stick on the crankshaft for these, and it helps. Now, with your lab partner, he can hold the engine while you break it loose. But what I quite often do is I put a section of pipe over this, and it uses as a leverage to prevent this from moving while I'm doing it. I got one here, but it's on the right side.
Yeah, so you can, put it like this, you put some weight over the shaft too.
So is that like a 5/8
Hold
shaft?
this, have somebody hold it, or this isn't the one I normally use, but a section of pipe, and as I do this, it'll hold this from moving while I'm breaking it loose. It's wrong size. I'll tell you what, let's do it like that. Just hold this. Like when you're doing it. Now I'm going to come through and just break these, turning each a quarter of a turn, and do it in a pattern going across diagonally so that you relieve the pressure equally on the component. And you just break them all loose. Now this should be all loose now. So,
Thank you.
and as you're working on this, that's what you can do. Now, what's nice about this breaker bar, I can swivel it up. And you can see that's fairly quick. Little things with the tools I want you to know how to do. You have different angles on your breaker bar. Now I use this as a driver. I can use the socket itself to aid in taking it off. And little tricks, you learn different things, ways to use the tools to go quick. Now I'm gonna, here's a, Mr. Clekus here. I'll try to do that. How's things going downstairs? Now I want to show you something. I'm going to back all these bolts out so that I want you to be observant when you do things. Tecumseh and Briggs and Stratton both do something interesting, and I want to illustrate that to you right now. I'm not going to remove any of these bolts. And other things you've worked on in the past, you've taken all the bolts out and thrown them in a tray, a box, or whatever. Instead, I'm backing all these out, okay, to where they're all the way out. See, they're now disconnected, but they're sitting in their holes. Make an observation. What's interesting about this?
Different lengths.
Different lengths.
What's that?
They're all different lengths.
They're not all different lengths, but there are varying lengths, right? And what do you notice? Is there a certain pattern about what's there?
Yes.
Smaller ones.
What did you notice, Dan? What did you notice?
Long here, shorter there.
Around the exhaust valve, the bolt is actually longer on certain engines. Take it out. If you doubt what you're seeing, take it out. Yeah, it's about a 1/4 inch difference. If you read in depth in the service manual, it will actually tell you that. The bolts located around the exhaust valve are longer to give it more engagement and keep the head tighter around that hotter area. The rest of these bolts are the same part number. So when you get a Briggs & Stratton, there's 5 usually, sometimes 6 with one number, and 3 long ones typically. Some engines have 4 depending on their application. This one right here has 3 long ones. When I pick this up, you'll see that the 3 are located around the exhaust valve. All right? Now, what you're going to do, you'll check this. Now, I put a reusable head gasket on this, but at this point, now that we know this, if I want to examine, and normally I should have taken this spark plug out by now, I know that this will be the case. I can do one of 2 things. I can leave the bolts in place, and set it aside and just set the whole thing over here together. No problem with that. At least they're in arrangements, you took them out when new. Okay? Now, from a safety standpoint, I don't like you messing with I don't like using the breaker bars on this because a lot of times people get tangled up. Something will spin or whatever. It's easier, and this doesn't always happen. Sometimes this flywheel is stuck to the crankshaft, but this one came right off. Now again, set this to the side, and everything that came off here, your recoil cup, your screen, this goes here. You had a shear pin, a shear key. Now here's an interesting thing that I'm going to tell you now. I could now, but this is a good time to do it. This is not just tear down thing. I want you to notice something.
Engine boxes. Who had an engine box? Let me see your engine box.
Your engine box.
Let me see it.
John brought in his engine
Your
box.
wooden frame.
Are you catching any of this?
Yes.
All right, now there's a couple ways to do this. We'll see how this works. As you can see, while this is handy, you get to put it over here. But I wanted to demonstrate your engine box. I wanted to be the first one to put some grease on it. That way you got something to remember me by. All right. I wanted to explain a mechanical thing. This flywheel, you might wonder, these flywheels will sometimes shear a key. It'll come unlocked, and now it's out of time. The key here, this little soft key, is put in here to time this flywheel to the proper spot. Notice without it, notice what happens. Don't you find that kind of peculiar? And to put it back together, you line up the groove, drop this in. This locks the key into place. Okay? And you put this back together like so. You put the nut on it and you tighten it. And like I say, this will tighten to 70 foot-pounds on this particular motor. But you'll notice now the crankshaft will move with the flywheel, correct?
Yeah.
One of the things that will happen if in the drivetrain of this something binds up and locks the engine up, and this flywheel, the engine stops suddenly, this flywheel can break that key and shear it. This is a common problem on small engines. On lawnmowers, you have a lawnmower that suddenly, maybe you hit a sprinkler, you hit a root. Anybody ever done that? Hit a root or sprinkler head? Have you sheared the key in the lawnmower before? You don't always do it, but when you do, you might notice that, hey, a couple things happen. Yeah, you hear the component going, or the motor suddenly stops and won't restart. Because if it shears the pin completely, it'll usually move it like 90 degrees, and now the engine's out of time. Because you got to remember the function of that. Close that door. See, I told you this would happen. What's going on, Paul?
When are you going to have a free moment?
It depends on, are we just doing one dance or two? How many songs are we going to dance through?
About 15 minutes worth.
15 minutes worth? Where will you be in, say, Half an hour.
Here.
At your office?
Well, I'll come over and talk to you.
Oh, yeah, just come back over in half an
In
hour.
a half an hour.
Yeah, that'd be great. You bet. So, here's the thing. This is designed to keep this here, but I want you to think of the mass. Obviously, if you look at this cast iron flywheel has quite a bit of inertia. It's got a lot of mass. If for some reason this engine throws a rod, or in the case of a lawnmower, it hits a stump, and it stops the blade with all this inertia, this has enough energy built up into it, it could potentially shear the end of the crankshaft off. Just break the crank. You with me? So they decided we need a safety feature here. How can we put this together in a way that we get the flywheel on here, but in the event of a sudden stoppage of the crank, that the flywheel's inertia doesn't damage these components. So they came out with a keyed flywheel. Believe me, they could have made the flywheel with a hex on it, or out around, so where you drop it on, it stays locked in place. But that doesn't fix the problem with it wanting to self-destruct, does it? Because like I say, if you try to stop this, that's going to just take that crank and twist it right up. So
So there's only one way that key line will line up?
yep.
There's a groove inside.
See, there's a groove in the flywheel.
Okay, what,
Here, let's pass it around. Here, Carson. Take it there. I don't know if you guys can see it over there, but let me walk it around. There's a groove on the taper. Now, let me talk about the other part of this. Everybody see back there? All right. Now, this is what let me make something clear. The purpose of this key is for assembling. That's all it's for. And setting the timing. You're indexing what you're doing with the key. Now, some people put the key in first and try to slide it over sometimes, but what the deal is made to put this is going to determine that the flywheel be installed in the right place. What really holds this in place is this nut on the taper. What happens now, the flywheel, as it goes around, you notice it has a reverse taper. This has a taper. How this works is, as you tighten this nut up and it pushes the flywheel down onto the crank, the key holds it in the proper alignment for timing, and the tightness, the torque you put on this, drives the flywheel down onto the taper and locks it in place. It is being held in place by tension between the two tapers. They will sometimes do this in drive systems, certain transmissions. They'll put a gear in a transmission and mount it on a taper. There's certain outboard motors they'll do this because they know that if you hit an obstruction, you can cause extensive damage. So what you do, if you put it on a taper and then put a soft key, which is, what do you know about soft stuff? What do you call that material? I mean, a component or a tool that sacrifices itself. Yeah, a sacrificial device. This is, look, these are cheap. These things are about 85 cents to buy. But it saves several $100s in components. Because what happens is, when the force is great enough to cause the flywheel to spin on this taper and shear the pin, that's what that pin's job is to do. To say, okay, I'm sacrificing myself for the team. I'm lowly, I'm not worth spit. You know, it's hard to have a huge ego when you're a shear pin. Because you're not all that.
without the, your,
Be glad, Bruce, you weren't born a shear pin.
I was, my wife calls me that all
Does she really? Oh my God. I don't
the time.
think.
Sacrifice yourself for the family.
There you go. There you go. How would it be?
But without it, the whole machine did fall apart.
Well, yeah, it'll actually twist the end of the. Like I say, they will really actually. Here's what sometimes happens. These on a flywheel are made of a sacrificial material. There's been knuckleheads that when that aluminum key sheared, they went and found a drive key off of like a pulley system for a belt, which slips on itself. You don't put a steel key in here.
It doesn't break.
Because, yeah, now you got a problem. Now, I want you guys, I told you, I don't want to just spew information on you. I want you for a moment think. Okay? When this is together, look, without the pin, let's pretend this is sheared now. And this is what it'll do. You see the flywheel is moving and the crank is not. Okay? I want you to think about this now. There is a point that as I half-inch ratchet, nurse ratchet.
I don't have that either. I'm coming in.
I picked the wrong
I know,
guy.
dude.
The guy has the bright green snap-on box in. Look at me.
And it's empty.
Look at all this cool. And
I got a half-inch drive.
It's on back order, man.
hey, buddy.
Come on, cut me some slack like Timothy.
Look. Exactly.
Yeah, come on.
You gotta have an example for each class.
Yeah.
I'm gonna
So
treat.
sacrificial
You know what?
lamb.
I'm gonna treat you like a priest. Now see that thing. Oh, it's got a rough thread on it. Yeah. Some of these have got boogered up.
So is that shear key like mostly in lawnmowers because lawnmowers are more in danger of like having a immediate stop like that than like motorcycles would be, or is this in all small engines?
You're showing off with your deductive characteristics. All right, now notice, as I start tightening this up, suddenly it's locked together. The key's not even in there, right? Yeah, it's the tension between the two tapers. So, I'm going to ask you this question. At what point, let's see, I loosen it up. Look, no, it's still there. It's actually stuck a little bit now, see? I can actually back it off. And see, once I push it down on the taper, it actually is locked in place. So it doesn't take that much. But let me ask you this. How critical, don't anybody say, how critical do you think the torque specification is on this? Why? Why is it critical? Like you said, that's got to be critical. Why is it critical? Anybody else?
You don't want the flywheel to come loose after.
That's true. But
The blade's causing resistance against the crankshaft.
See.
Catches more
well, it has its
resistance
own
than-
inertia too.
Right, but if there's more torque against the blade than is on there, then
Just see
it'll
good
strip
taper.
it.
All right, these engineers decide they want a certain amount of what we call breakaway pressure. Well, when you have a taper, you actually engineer how much force it's going to take to actually break it loose based on the torque applied. The more torque you apply on this, the more pressure it's going to take to break the flywheel away from the crank.
So you motor torque it, even with the key, it's so sure.
You can split the flywheel in half. Because first off, a taper is like a wedge, right?
Yes.
So it's wedged on. So you got cast iron. Now this is why I started one of the stories I told you about the little Navy guy that came in here that came to the aid of that one girl. Remember I told you he had the gun the wrong way. He goes, next thing you know, the flywheel, clink. The flywheel broke in half. Okay? Because if you have that taper in the flywheel and you tighten it too far, the very principle that it's built by, you exceed the pressure, you'll split the flywheel. So over tightening it can split it because it acts like a wood wedge. You keep driving that wedge down into the log, you'll split it, right? Well, I want to get you that visual. From that standpoint, over tightening it can split a flywheel. So do you want to over tighten this? No. But Bill, do you want to under tighten it? Because then your breakaway pressure is too light. And guess what's taking the load now? That little teeny pin is now, if you're one of those knuckleheads, I've seen guys working on their stuff at home, go out here and go, oh, I put that flywheel back in, I dropped that pin down there, hold that thing in place, and then that's all it needs. Yeah, I don't take it too tight, I take it tight enough. You got that pin holding it there, it'll be all right.
So what is over tight, what's under tight?
So what happens is, you get an obstruction, and it shears too easy. And now the thing's out of operation, it's not running. And for some people, they don't know what's up, so the shop it goes. Call it easy. Well, here's what's funny. You would not believe how many times I've gone to one of those lawnmower shops or found a lawnmower in a dumpster and took it home and found the only thing wrong with it was a pin shoe. For 85 cents, I fixed a snapper that was worth $320. What's wrong with the lawnmower? I don't know, I hit a stump and it quit. Tilted up, and I tilt around, the crank's not bent. Now, if you usually have a bent crankshaft, it's usually totaled. But I can straighten some cranks. But the point is this, is that knowledge is power. Now look at stuff you got. You can't believe how many lawnmowers I've had sheared pins and plug main jets on, and they throw them away. And some of them are cheap mowers, some of them are expensive mowers. I've had people throw away $500 mowers over an 85-cent part. It's ridiculous. Good way to make money. So, anyway. I thought while I was right here, I interrupted the teardown because there's no better time to describe this than right now, when it's right here. Now, once I tighten it, it locks back on, but since I didn't torque it too high, it came off easy enough.
How would you get it off if it was
Just tap it.
What's that?
How would you get it off? You said cranked all there.
Well, you have to use the hold on. You have to use your torque wrench. Oh, you mean how do I break? If it's stuck on?
Yeah.
You can tap it with your brass hammer. Now,
Yeah, I think so.
later down the road, if this one is stuck, I would have demonstrated that, but that's a good point. Let me tell you about that real quick. So what we do is we put the nut back on the crank, and Tecumseh made what's called a knockoff tool. Some of them have a flywheel puller that has a threaded pusher on it that pushes to the center of this. Most of these, though, if you take your brass hammer and you take a pry bar and lightly lift on the flywheel, take this nut and put it flush with the end of the crank, it's going to have an air gap. So you lift up on the flywheel with your pry bar, take your brass hammer, shock it, just tap it, and it'll break loose. Now, if you have a real bad one, it might take a little more than that. And I'll show you that going down the road too.
So, blaster be a recommendation? If it's
Sometimes putting a penetrant like PB Blaster on it first will help break it away. All right, now at this point, we're going to be taking the internals out, but I want to make a couple comments. This is the governor assembly. which is a whole different lecture. I do not want you taking any governor assemblies off during this initial teardown. This has to be indexed in a certain way. I don't want you removing it. For what we're doing on this first exercise, I don't want this touched because it takes too much time to explain it to you when we're going to have a dedicated period in the next semester to talk about all these related systems.
Bill,
All right, yes.
is there a reason in production that they don't have the cylinder separate from the case?
It's cheaper.
What do you say?
He says there's a reason why this cylinder doesn't separate from the case. Certain motorcycles do that. Fewer and fewer manufacturers are making separate cylinders. Because one, if you have a cylinder base gasket, you have a cylinder and the head bolts loosen it all, your cylinder's moving and rocking. They found out it promotes oil leaks, blah, blah, blah. In manufacturing now, they say it's cheaper to build as one unit. There's fewer problems with one unit. Because normally, if you damage the bore anyway, it's too expensive to fix, it's a throwaway. So a lot do not have it for that reason.
Can those still be honed out?
Yes, they can be honed out to an oversize. This engine right here, for some reason, does have a brand new piston in it. I can tell by, oh, you know what?
That's brand new.
I remember who did this. You see these, what happened to the other end of my soft jaw here?
Fell off when I was trimming.
Why didn't you put it back, Kyle?
He's back here.
All right, we got it. Now, look, these are called soft jaws. So if you put something like a crankshaft in it or something, it will help prevent marring on it while you're doing something. But we actually had this very special kid in here. He was a little odd. He wanted to measure, he wanted to aid putting the rings on, and he stuck the piston in a vise with soft jaws and cranked this up. No, in a minute when I get this out, I'll tell you what you think will happen if you clamp the skirt of a piston in a vise. Any idea? Well, it deforms it. He came to me later. This is during an engine teardown. In this case, here it is. It was a teardown like this. He's going back together, and he goes, "My piston doesn't fit my engine." I said, "What are you talking about?" He goes, "My piston won't go back in the engine. It seems to be too big." Because as he cranked in on the skirt, it made it oval. Now it was wider in one spot, and it wouldn't go back in. So I look at it and I see these little marks on the skirt. And I literally went over and I saw the impression of the soft jaws in the skirt. I said, "Tell me, Jeremy, is there any chance?" Oh, by the way, this is not Jeremy Finch. This was not Jeremy Finch. This was this one kid, his name happened to be Jeremy too. I said, "Is there any chance you may have put these in a vise?"
I've never heard that.
Oh, let me think. You know, I think I did. I found it hard to hold the piston while getting the ring off, so I put it in the vise while I took the rings off. Thanks, Jeremy. All right. Now, here's an extra thing if you want to do it. You have your feeler gauge on it. The other one, multi-blade. You can get an idea of what your clearances are. Now, we do know that on this engine here, I want to know, do I have some clearance here? We know it should be around 7 or 8 thousandths for the intake. I want to see at least I got 6. Oh, this was tight. All right, that's good to know when you tear it down. All right, I can tell now this one is a little tight. Starting off, I try to check this. I can't even get the 6 in there. And nor it's 5 to 7, I think, on this. Let's see what we got. This feeler gauge set here doesn't have a lot of options. Let's see if a 4 goes in. All right, this is really strange. This engine has a really tight intake valve, and this will be a candidate for adjusting. Anyway, go to top dead center, and check how much we got. Now, if you look at the spec, it should be something like between 5 and 8. And I can't even get a 4 in there. So I'm not sure how this happened unless we put a new valve in it and he didn't adjust it. Here's 2. All right, this is odd. I think somebody's put a new valve in this.
Zero clearance.
Yeah, there's no clearance. And the new valves are made longer and you have to grind them to size. So later on, I'll show you how to grind this. All right, in the meantime, the other one had clearance. So that's good to know right up front. I could barely start the 2 in, but it wouldn't go. I know I need to take about 4 thousandths off that. We'll do that later. All right, now, here's what I want to show you. There is a notch in this. Now this one's pointing out. The notch, you should be able to see the notch, and with your finger here, you put this spoon in, you push it in with this recess hitting the retainer. You simply lift up and pull out, and the valve is released. That easy. Continue to lift, and I'll let you see how this mechanism works. It goes on here, and when you push up, you have a big hole, you push up, and then you push in, and it locks it. Now, with the spring tension there, it stays in place. I'm going to pass it around and let you see how that works.
What's that tool called? Joe, what's that tool called?
That is this is a valve compressor tool. We went over, I don't know, were you there that day when we went over this? You might have been missing. We showed everybody where they were online. You can buy them. Because the option, now you tell me what you'd rather do. Here's the option. You can go in here like this. Oh, and I got to flip this upside down for this application. I'm already spending too much time. I can do that. Or I can use this other valve spring compressor and go through this and tighten it up and all that. Or you just slide this in. Now, with that little notch, it tells you what side gets pointed out. What this little hook is for grabbing the notch and swinging it out to where you see it. Now you go in. I'm sorry, but that is just too damn easy. Come on, really?
So Bill, this is fitting in there this way, and you're pulling it. When you grab a hold of that with a tool, you're pulling it up and then sliding that underneath.
I'm pushing it up and then moving it out. See where the notch is?
Yeah.
See, the notch is out. So when you push up and pull out, it unlocks it.
So it's sitting in there this way, and you, with that hook, pull under.
I'm
pull
lifting
this
it up, pushing up, yeah.
And then you slide the fork
and pulling
underneath
out.
it. Okay.
Yeah.
Thank you.
Now, with that on there, I can actually take this and Now, some guys, if they want to use it this way, they'll flip it upside down. Certain parts like lifters and stuff, you can do that. Or you simply just stick it in here like that. Some guys will put these in the small holes. And they'll label them exhaust, intake, whatever. See what I mean? All right, so now,
And are these the same, the exhaust and the intake on this Briggs?
no, they are not. That's why you have to distinguish. The intake valve is bigger than the exhaust. So you separate. The valve spring itself is different.
Thank you.
So retainers, valve springs, you have to look at. There's a different, and matter of fact, I didn't notice if this was put together right. The exhaust spring, let me see that spring real quick. Let's spend some time here. The exhaust spring in some Briggs 5 horses, the spring itself should be longer. Guess what? Is it backwards?
This exhaust spring should be longer.
Here's the exhaust valve. They put the spring. Now you can put that around the other one.
Bill, if they're backwards, could that account for the no gap?
No, but you know what? And a lot of them go together that way and run just fine. But for longevity, because of the extra heat and stuff like that, they make the exhaust longer. So, but that's a good thing to spot.
And the spring on the exhaust is usually longer?
Yeah, again, refer to your Briggs & Stratton manual, because sometimes they'll reverse that around. This was yours, right?
No.
Oh, that was mine. All right, so now, back to your 3/8 set. Hand me a 3/8 socket, deep well. No, 3/8 one in your throat. And I want the deep. Merci beaucoup, as they say in France.
Wrong one?
I need a new nurse. I'm canceling dinner reservations. I know you shaved your head, but you're really a blonde, aren't you? The nice thing about this box too is you get to move the engine around to the edge and give you more clearance to get on things. Now you see again while I'm doing this, why I use a deep well. It just keeps me off of things. And another thing, doing this box, you can see how much more convenient it is to sit it on this box and work than sitting it on the actual bench. When they don't have a release, a lot of snap-ons don't, find out the easiest way to get the socket off is do that little tap. Now, I like to use this as my driver. Again, you can do the same thing on this, but I know already, well, you guys don't. You can bring all the screws out together. Because sometimes on crankcases and things like that, if they have a bolt that goes down through the middle of a dowel, they'll make the bolt slightly longer. This is not the case for this, but at the same time, I'm showing you as a habit, it's good to back all the screws out and see how much of a how much standoff they have from the part. And what I mean is, how much clearance is there between the part and the screw when it's already all the way brought out. You see they're all the same length, but at the same time, if you haven't taken this thing apart before, as you pull it out, check the lengths. Be smart. Does it look like all the same length to you? They are. Once you do that, it doesn't matter about the order. can go ahead and put them together. Plastic hammer.
It says.
Now, right here where the extension is, you pull this off, you'll see that there's a gasket here, and there is the governor mechanism. We're not going to mess with any of this. We're going to set it aside. At this point, you can transfer these. If you're more comfortable with having the bolts in the cover, you can put the bolts back in the cover to keep it together. Okay? That makes it easy. Now, we have this set up. Now we're ready to remove the piston. Now what we've got here, to get to those bolts, it's easier to rotate this down and get the piston, get this rod totally exposed at the bottom. And position it where you can access the connecting rod. I'll let you guys look there. So now I'm going to move it to the bottom of the stroke so I have access to the rod bolts. Now this is what I warned you about, guys. This is where people screw up. Do not put a 12-point socket on that bolt.